The next special function register of PIC16F887 that we are going to study is option register. So, to define option register is a 8-bit special function register of PIC16F887. As the name itself indicates, option register will give us the options to configure various features of the microcontroller. So, the option register is readable and writable register which contains the various control bits to configure. So, let us see the options that which we can configure using option register. The first thing is timer 0 or WDT, that stands for watchdog timer prescaler, external INT interrupt, timer 0 and weak pull-ups on port B. So as said, it is a 8-bit register. This is a bit configuration of the option register. So bit 0, bit 1, bit 2 stands for PS0, PS1, PS2. That is nothing but the prescaler rate, and PSA, that stands for prescaler assignment, TOCS and TOSC. So these both are to configure the timer 0 options. INT EDG, this goes for interrupt, and RBPU, this goes for weak pull-up enabling. So let us see each bits individually. Bit 7, that is the most significant bit of option register. So this bit is for RBPU. So you can see the complement on this particular pin. So this is the active low pin. So RBPU stands for port B pull up enable bit. So port B, we have 8 pins. So all these pins can be used under pull up options. So if you want to enable it, so this bit, that is bit 7 of option register, must be made 0 because it is active low pin. So if this particular bit is 0, then port B pull-ups are enabled. So if this bit is 1, then port B pull-ups are disabled. Next, bit 6, that is INT EDG. This stands for interrupt edge select bit. So we all know hardware interrupts are nothing but the external pins that are available on the microcontroller to provide options for interrupts. That is, external devices will request the microcontroller for service using this pin. So if at all this bit is made 1, that is bit 6 is made 1, then interrupt will be enabled on the rising edge of the INT pin. So if this bit is 0, interrupt on falling edge of INT pin will be enabled. Next, bit 5, T0CS, that this stands for timer 0 clock source select bit. So we all know that there are 3 timers available in PIC16F887 microcontroller: timer 0, timer 1 and timer 2. So here timer 0 can be used as timer as well as counter. So basically timer is nothing but a register which keeps incrementing. So if at all you are working it as timer, then this increment will happen during the internal clock, with the internal clock frequency. Counter means one which increments when the external events happen. So if at all you want to use this timer 0 as timer or counter, you must configure the bit 5. That is, if this pin is 1, your timer 0 will increment on the transition on T0 CIK pin. So this is the pin that is available in PIC16F microcontroller. So that means this is the external pin. So when there is any transition on that particular pin, timer 0 increments. That means I tell timer 0 is working as counter here. So if bit 5 is made 0, then the increment will happen with the internal clock frequency, that is internal instruction cycle clock, that is F oscillator by 4. So to conclude, I tell T0CS, this bit is to tell whether your timer 0 is working as timer or counter. So if this bit is 1, it is working as counter. If this bit is 0, it is working as timer. And then bit 4, T0SE, that is timer 0 source edge select bit. That means now if there is any transition in T0CKI pin, your counter starts incrementing. So whether it is from high to low or low to high, that can be configured using this bit. If this bit is 1, then timer 0 will increment when there is transition from high to low. If this bit is 0, it increments when there is transition from low to high. Next bit is bit 3, PSA. This stands for pre-scalar assignment bit. Pre-scalar is nothing but frequency divider. If at all you want to divide frequency, yes, that option is available in PIC16F887, but that can be done only for watchdog timer or timer 0. If at all pre-scalar has to be assigned to watchdog timer, then bit 3 of option register must be made 1. So if this bit is 0, then the pre-scalar is assigned to timer 0. Now bit 2, bit 1, bit 0 of option register will tell you the rate of the pre-scalar. So if all 3 is 0, 0, 0, then 1 is to 2. That means your frequency will be divided by 2 for timer 0, and 1 is to 1. That means there is no frequency division happening for watchdog timer. So if these 3 bits are 0, 0, 1, then for timer 0 it is 1 is to 4. For watchdog timer it is 1 is to 2, and so on.